Alright, we're going to look at general form here. There's a few forms for linear equations, right? Any linear function can be represented by a linear equation. Linear equation is any equation that can be written in standard form expressed below. So standard form is ax plus by equals c, where a, b, and c are real numbers, right? And a and b are both not zero. Any ordered pair that makes a linear equation true is a solution. So if you get an equation that makes the two sides equal, you have a solution. The graph linear equation represents all those solutions, right? So determine whether the equation is linear. If so, graph the function. So here we got one. This one says, it looks like it, ax plus by equals c. Alright, the equation is linear because it's in standard form of a linear equation, where a is 5, right? B, that number in front of y, is 1, and c is 10. To graph the function, first solve the equation for y and make a table. So if we plug in -1, 15 comes out, 0, 10 comes out, 1. That's just plugging in x values and getting y's. Alright. Note that because the range and domain or the function non-horizontal line are real numbers, the graph is continuous. We don't have discrete points. So let's try this. Ready? This equation, once again, there's a is -4, b is whatever's in front of y, in this case 1, and c is my constant 11. So it's linear because it's in standard form. Alright. A is -4, b is 1, c is 11. And if we plug stuff in, so what happens when I plug stuff in? Alright. I plug in -4, I've got -4, I'm just plugging into this equation. Alright, times the x value -4 plus y equals 11. That's 16 plus y equals 11. Y equals -5. We're going to see something really soon. I'm going up by 2, so -2. Again, I'm plugging into this equation. -4, that's a terrible 4. -4x plus y equals 11. So if I plug in 2, right, x equals -2. -4 times -2 plus y equals 11. 8 plus y equals 11. Subtract 8, y equals 3. Oh, I feel like I went up too much. Oh, I subtracted 8. Did I subtract 16 from the other side? Well, maybe I didn't. Let's keep going one more, see what happens. No, that's right. And now y is x is 0. We skipped one. It's not a. So if I go x equals 0, right? That's -4 times 0 plus y equals 11. And these cross off and you get y equals 11. I can see this going up by 8 every time. Alright, so this one's going to be 19. 8 more is going to be 27. Let's plot it if we can. So we got what? -2, 3, 4, and -5, which is probably right in there, right? If this is -10, looks like it goes by 10s, halfway. -2 and 3, probably right there. 0 and 11, right about there. 2 and 19, somewhere in there. Maybe I'm a little high for that 11, maybe I'm a little low right there. And 4 and 27, right about there. We can see we have a linear equation, or at least a really close estimate. I might have put my points in the wrong spot. Alright, so write an equation that is linear but is not in standard form. Well, we know y equals 3x plus 4 is slope-intercept. If a is 0 in the equation written in standard form, how does the graph look? Well, let's see. If I got 0x plus 3y, well, let's just say plus y equals 7. That just gives me y equals 7. Well, if y equals 7, that would be a horizontal line, right? I'd go up to 7, and y would always equal 7. So this would be a horizontal line, which is no slope, right? It just goes, y is 7 no matter what x I plug in. Determine whether that's a linear graph and graph it. Well, let's do it. All right. Yes, because it's in standard form. All right, where a is 6, y equals 1, c equals 12. Let's plot a few points. So if I plug in x and get y, let's plug in 0 because 0 is easy. All right. So 0 times x plus y equals 12. y equals 12. 0 is always easy. Let's plug in 1. That should be 6 times 0. This can be 6 times 1 plus y equals 12. 6 plus y equals 12. Y equals 6. Right? Let's plug in 2. That would be 6 times 2 plus y equals 12. 12 plus y equals 12, and y is going to be 0. I think we got enough here. So I got 0, 12 somewhere around here. I've got 1, 6 somewhere around here. And I've got 2, 0, and we've got a line that goes forever in both directions. And there it is. Alright, I'm going to stop here. Looks like we got like a page and a half to go. Next video.